This is a presentation for EE542 lab3 fast reliable file transfer. So before we start, I would love to give you an introduction of this lab. So based on the first lab, we will explore the real-world implications of how TCP performs under less than perfect conditions. Although TCP can provide reliable data transmission, but the transfer speed is not ideal, so especially comparing to UDP protocol. So the goal of this lab is to develop a protocol that can obtain both fast and reliable features. There are three basic conditions required that we have to achieve in this lab. So first of all, we have to add 200 millisecond delay at both sides and 20% loss in total. The second is that our program should be capable of sending at least 1 gigabytes file through this protocol. And the last is that we have to reach the speed limit of 200 megabits per second. So there are some essential commands that I want to mention. In order to add the delay and the 20% loss, we can use the following command: the sudo tc qdisk set dev emps0. The emps0 is the host name, and then root netum delay and loss. And the second command that is important is the ping command, that we have to use this command to ping server and client together. So as you can see here, these two IP address are the static IP address for server and client accordingly. And then we can compile both server and client codes, and then we can transfer the files. So before we talk about the codes, I think it's also important to talk about the design principle that we have implemented in this lab. So for client side, we are creating two sockets. The reason for that, we will explain it later. And then we add 200 milliseconds delay, 10% loss, and we have to use the condition that to request a file to send by input from the keyboard of the file name. And then when we accept the packets from the server side, we have to save it to the buffer. And then is the condition that when there is out of order packets, we have to send a resend request in order for the reliable service. And we need to send acknowledgement packets when we already received all the expecting group of packets. And finally is that we have received the packets and already saved it in the buffer. We have to write the data into files when buffer is full, so we can clear the buffer for the next group of packets. On the server side, it's much more easier. We are creating two sockets also, and it's the same delay and loss. And then the main job of server is to sending packets to client. And when there is a resend request being received at the server side, we have to resend the packets that we're being requested for. And when we receive the acknowledgement packets, we're gonna send the next group of packets. And next part, we'll talk about the codes, those essential parts that we utilized in this program. So first of all, the code for creating sockets. So in this part of code is very similar to the lab 1. We are creating sockets on both server and client side for the data communication, so that they can talk to each other. In this lab, we're using UDP sockets instead of TCP. Because there is no handshaking and stuff, it's gonna be much more faster. As shown in the figure, this is a process. We're creating a UDP socket. We have bind, we have receive from and send to. So next part of the code is the server side we're gonna talk about. So there are two main functions for the server: creating two sockets, as we mentioned before. One is used for receiving signal packets from client, one is used for sending data, so that we can avoid have the data collision that will affect our transfer speed very much. And the second function for server is to send data that are needed from the client side. So if client send ACK, server will send next group packets. If client send resend request, the server gonna send exactly the packets that the client wants. Next part is the client part. Also is the most important part of the code that we write. The packets received in orders in our design, so we're sending packets as a group. The group size is equal to the buffer size. When the buffer is full, and then when we receive the next group signal from the client, we were starting to send the next group of packets. So each time we receive data, we will scan the buffer. When there is a packet missing or out of order, then the client will send accumulate ACK to request the server to have the next package to send. Then the server will send that packet again. Then we can scan the buffer again. Once the buffer is full, we can change the thread to write. So just for your information, the buffer that we use here, the size of it is 1024 bytes. And these are the figure to show like how buffer looks like. Next part of client code is a main thread. So this is the same with normal TCP ACK packets. When we receive the packet, then the client will scan the buffer and will send out of order packets as ACK to server to tell him that I have already received some part and please send me the next group. And for the client write functions, for one group of packets, once buffer is full, which also means that we have received the group of packets in order, then we change thread to write those received data into files. Then we can clear out the buffer for the getting ready for the next group of packets gonna arrive later. Here we had two screenshots of our results. As you can see in the pictures, that we have received exact the same file with the same size for the client requesting. And you can see the transfer speed in the demonstration video later. So now I'm gonna show you the demonstration of our program. Okay, now we open this client file for the demonstration. So first of all, we have to ping the client server machine. So we use the command ping and then the IP address for the server machine. And as you can see, we have already added 200 milliseconds delay and 20% loss. Okay. And now we input the file that we want to receive from the server. And this one is like a small file. Let's try the speed first. And as you can see, we can reach the speed of around 21 megabytes per bytes per second. And then let's transfer the bigger file. This one is more than 1 gigabyte.